Hello and welcome. In today's lesson, we are going to look at matrices. It is also known as matrix algebra or matrix theory. So we are going to look at the order of matrix. We are going to look at the elements in a matrix. We are going to look at how to add and subtract matrices of the same order. And then we are going to look at something known as scalar multiplication. And then lastly, we will look at multiplication of matrices. So let's go ahead and start without any wasting of time. So it is advisable that you get your pens and books ready so that we can work together. So firstly, you need to identify the order of the matrix. So order of matrix. So if you are given a matrix, you need to identify what is the order of that matrix. So if we're having a matrix 2, 7, 4, -4, 6, 3, and 5. So the order of this matrix, we check here, we have first row and second row. So it means that this matrix has 2 rows. Then we look at here, when you read vertically, we'll have 1, 2, 3. So it means that we have 3 columns. And this is the R represent rows and C represent columns. So what is the order of this matrix? It has 2 rows and 3 columns. So it's a 2 by 3 matrix. So that is the order of the matrix. So if we want to identify elements in a matrix, so we can represent that matrix in this way. 1, 1. 1, 1 means first row, first column. First row, first column. Then 1, 2, first row, second column. 1, 3, first row, third column. Then 2, 1, second row, first column. 2, 2, second row, second column. Then 2, 3, second row, third column. So how do we identify the elements? So if you are asked to identify, this is a simple question. Obviously you won't be asked, but it's important that you know how, because you will use it in the future. So identify element A1, A11. Element A11, it's the number which is on the first row and first column. So if we were to identify in that matrix, we say that it's actually 2. Then maybe 2, 3. This means that second row, third column. So there it's 5. It's this one here. A12, element A12, this is first row, second column. First row, second column, it's 7. Then 2, 1. So in that manner, you can identify all the elements in a matrix in that way. And this is very helpful when you are continuing with this matrix operation. So because now that we know how to identify the order and we know how to identify the elements in a matrix, what we need to do is to know how to add, and we also need to know how to subtract matrices. So according to the rule, in order for us to add the matrices or subtract, they have to be in the same order. So now we have A, which is equal to 2, 3, 5, and minus 4. And then we have matrix B, which is 7, 4, minus 3, and a 5. So we can see that this is a 2 by 2. Now we know how to identify the order of the matrix. So we can say without hesitation that we are having 2 by 2 matrices and we can add them. And how do we add them? Just going to say A plus B. So we add the same elements together of the position of the elements. We can see that here 2 it's 1 1 and 7 is 1 1, so we're going to add them together. So it's going to be 2 plus 7. Then we can see 3 and 4 are on the same position, so it's going to be 3 plus 4. Then 5 minus 3, because we have a negative 3 there. And then negative 4 plus 5. So that's how we add. So now we just need to find the result there. 2 plus 7 is 9. And then 3 plus 4 is 7. 5 minus 3 is 2. Then negative 4 plus 5 is 1. Then we have completely added there. How can we subtract? It's going to be the same thing, but now we are subtracting. So it's going to be 2 minus 7, then 3 minus 4, 5 minus negative 3, so it's going to be plus 3. Then negative 4 minus 5, like that. Then we'll get the result. And we can see that the resulting matrix, it's still on the same order of 2 by 2. So 2 minus 7 is minus 5. 3 minus 4 is minus 1. 5 plus 3 is 8. Minus 4 minus 5 is minus 9. So we are not going to look at another example on how to add and subtract. It is pretty straightforward. So let's go and look at scalar multiplication. So we will call scalar K, and this can be a number or it can be a constant. So if we have matrix A, it has elements A, B, C, D. Multiplying by a scalar will multiply K by A. So it's actually K times A. Then it's going to be K. We can put it outside first. Then A, B, C, D. So what we need to do, we multiply throughout the elements there in the matrix to get the final answer. Then we'll have KA, KB, KC, KD. So that's how we multiply with a scalar. It is pretty straightforward. And then we can see that if we're having something like this, negative 2, then 3a is going to be what? It's just going to be 3. We put a 3 outside. Then negative 1, 2, 2, negative 2. Then we multiply throughout by 3. We get negative 3, 0, 6, then minus 6. So that is straightforward. So we can go ahead and look at multiplication of matrices. And so far we can see that what we have been doing up to now, it has been very easy. So in order for us to multiply matrices, it says that we know that this represent rows times columns. So if here I have matrix A and let me just have rows times columns, it's the order of a certain matrix. So if the number of columns on matrix A is equal to the number of rows on matrix B, we can multiply. So we can say it fits the multiplication rule. And then if these values here, actually those values, they show us the resulting matrix. So we'll see how it works. So let's look at an example in order to understand what is happening. So if we have matrix A is equal to 4 minus 2, 1, 5, and matrix B is equal to 2, 3, negative 3, 5. So we can see that we have a 2 by 2 and a 2 by 2. I advise students to do it this way before they can continue to multiply. So we can see that the number of columns on matrix A is equal to the number of rows on matrix B. So it fits. And the resulting matrix that we're going to get is going to be a 2 by 2. So what we need to do now is to go ahead and multiply. So A times B is equal to, we can write them like this, firstly, to show that they are multiplying. But if it's a 2 by 2, it's not very difficult to multiply. So what we need to do, we can see that the equation says rows times columns. So we start with the first column of matrix B and multiply. We start with the first row of matrix A and multiply the first column of matrix B. So let's see. We already know that the result is going to be a 2 by 2 matrix. So let's prove that. So 4 times 2, it's 8. So we are still on the first row of matrix A and the first column of matrix B. So negative 2 times negative 3 is plus 6. So we have to add that. Then we jump with the same row of the first matrix. Now we take 4 and multiply 3. Let me remove this. So we said it was 4 times 2, it was 8. Negative 2 times negative 3, it was plus 6. So we are still on the first row of matrix A. Now we multiply here now. So 4 times 3 is 12. Negative 2 times 5 is minus 10. Then we are done with using the first row to multiply the columns on the second matrix. So we do the same thing. Say now we are on the second row of matrix B, of matrix A. So 1 times 2, it's 2. Then 5 times negative 3 is minus 15. Then we are done with that column. We need to use this same row and multiply here. And we know that we multiply with the same elements. So we have 1 times 3. 1 times 3 is 3. Then 5 times 5 is plus 25. So actually this is AB. So what we need to do now is to add those numbers that are inside there. 8 plus 6, we get 14. 12 minus 10, we get a 2. And we can see that the order is actually the same. 2 minus 15, it's actually minus 13. 3 plus 25 is 28. So we know that in mathematics, 2 times 3 is 6. And 3 times 2 is still 6. But it turns out that in matrices, A times B is not equal to B times A. And we will see that when we look at this. So let's work on the same page so that we can see that we won't get the same we will not get the same matrix as we got them. So let's do, because now we have done matrix AB. So let's do BA. This tells us that now BA, the first matrix is B and the second matrix is A. First matrix is B and then the second matrix is A. So if we do it there, it's going to be reversed. It's going to be 2 and a 3 and minus 3 and 5. Then we have 4 minus 2, 1, 5. So we do this, we use the same thing. We start with this first row and multiply the first column. Then when we do that, BA is going to be, we start with 2 times 4, it's 8. Then 3 times 1, it's 3. Then we are done with that. Even if we can put this inside the bracket to show that now we need to skip, we need to deal with this column, but using the same row. 2 times negative 2 is negative 4. 3 times 5 is plus 15. Then we are done with the row, the first row of the first matrix. Now we need to come to this row here. Then we have negative 3 times 4, it's minus 12. Negative 3, not negative 3, but 5 times 1, it's going to be 5. Then we jump. Now we need to go to the second column of the second matrix, which we are multiplying it by the second row. So minus 3 times minus 2 is positive 6. Then 5 times 5 is plus 25. So it's BA here. It's also BA. I keep on writing B. So it's BA. We just need to add the result. 8 plus 3 is 11. Minus 4 plus 15, 11. Then when you add, you're going to get these numbers here. You can check that with the calculator. Then we can see that AB is not equal to BA. So that is another thing that we need to bear in mind when we are working with matrices. So let's look at when we have matrices of different orders, because we looked at 2 by 2. So if we have matrix A which is a 4, -2, 1, 5. And then B is simply 3 and 2. So what are we having here? We have a 2 by 2. It's 2 rows, because we know that this represent R times C. So this side we have 2 by 1, because we have 2 rows and it's 1 column. But what we can see that is the columns on the first matrix equals to the rows on the second matrix. So it fits the rule. And then we have 2 and 1. This shows us the result. So we are going to get a 2 by 1 matrix. That is going to be our result. So we're going to get a matrix that consists of 2 rows and 1 column. So let's do it. So if we have A times B, then we'll have 4 minus 2, 1, 5. Then we can place this here, 3 and 2. So we can see that we start with this row and multiply. So AB is going to be 4 times 2, 4 times 3 is what? It's 12. Is it 12? Yes. 4 times 3 is 12. Then 2 times -2 times 2, it's -4. So since we are done, we do not have another column there. We only have 1 column. Then we jump to the second row of the first matrix, which is 1, 5. Then we need to multiply 1, 5 and 3, 2. So we know that 1 will multiply 3, then we'll get 3. 5 will multiply 2, and we get plus 10. And then the resulting 12 minus 4, it's an 8. 3 plus 10 is 13. So we are done with that. So what we need to know that if, let's check the value of AB. So if we're having AB, it's going to be 3, 2, then 4 minus 2, 1, 5. So we can see that we have 2 rows and 1 column, and we have 2 by 2. So the columns on the first matrix is not equal to the rows on the second matrix. So this one we say that is undefined. So if you are having this case, do not try to want to puzzle it. Try to ponder and just write that it's undefined. So it is very important that we check before we can proceed with these matrices. So let's look at another one. If we have A equals to 2, 5, 6, and so here we can see that we only have 1 row and 3 columns. If we have B equals to 3, 4, minus 5. What are we having? We have 1 row, so it's 1 by 3. 1 row, 3 columns. And then on B, we have 3 rows and 1 column. So we check here. It fits the rule. So it means that what we are going to have it's going to be a 1-by-1 matrix. So that's what it tells us, and it fits the multiplication rule. So let's look at AB. So AB, we can see that we'll take 2 and multiply 3. So 2 times 3 or then plus 5 times 4, 5 times 4, 6 times plus 6 times negative 5. So we do not have another row there. We only have one row, so we are done. And we know that we keep on adding until we are done multiplying the row by the column. So we can see that what we're going to have here is going to be 6 plus 20, then minus 30. Then the answer to this is going to be minus 4. And this is a 1-by-1 matrix. So it means that our concept is true. So let's look at the last one. But if you have seen, it's not very difficult. Let's just look at, because I realize that we've been using 2-by-2. Let's look at this one. 4 minus 2, 3, 5 minus 6. And then B equals to 5, 2, 8 minus 1, 3, 6, 4, 5 minus 2, 9, 7 minus 3. So we can see that this is 2 rows. So it's 2 rows times 3 columns. And then this is an advice to students. You must always identify the order. So this side we have 3 rows times 4 columns. So this shows us that it fits because these numbers here are equal. And then it means that the result will contain 2 rows and 4 columns. So let's write it. If we multiply AB, we are doing AB. So AB, can write it like this. So we have 1, 4 minus 2, 3, 5 minus 6. Then multiply by 5, 2, 8 minus 1, 3, 6, 4, 5 minus 2, 9, 7 minus 3. So what we can realize about matrices is that they are not very difficult, but just because it's more like it's a pattern, so it's very easy to make a mistakes. It's very easy to make a mistake. So I can see that because I'm just going to have 2 rows, I can see it tells me that I'm going to have 2 rows and 4 columns. So I will use the first row now. So 1 times 5. So now I'm dealing with this first here. So let me put this here so that it does not disturb our space. So I'm dealing with the first column, multiplying with the first row. So 1 times 5. 1 times 5, it's 5. Let's put this in bracket. And we know that we stop adding until when we are done multiplying throughout that row. So 4 times 3 is 12. So it's going to be plus 12. Negative 2 times negative 2. So it's going to be plus 4. So we are done with that first column. We move to the second column, but we are still using the first row. So 1 times 2, we are no longer adding now. We are going to, this is the value of the first element, if just as a reminder. So 1 times 2 is 2. 4 times 6 is 24. Plus negative 2 times 9. So it's going to be a minus 18. Then we are done with the second column. Now we move to the third column. And then we know that once we are done, we don't add anymore. So similarly, 1 times 8 is going to be 8. 4 times 4 is plus 16. Negative 2 times 7 minus 14. Then we go to the last column. 1 times 1, it's minus 1. Minus 1. Then 4 times 5 is plus 20. Negative 2 times negative 3 is plus 6. So we were able to complete the first row of our resulting matrix. So we do the same. Now we go here. And then we are on the second row. So we're going to multiply by the first column. So let me just get rid of these arrows here so that we can see if you missed some steps on how we did the first one. So we are on the second row. We multiply with the first column. So 3 times 5. 3 times 5 is 15. Then 5 times 3 is plus 15 again. Negative 6 times negative 2 is plus 12. Then we are done. We go to the second column. We repeat the same. 3 times 2 is 6. 5 times 6 is plus 30. Negative 6 times 9 is minus 54. Then we are done. Then we move to the third column. 3 times 8 is 24. 5 times 4 5 times 4 is plus 20. Negative 6 times 7, that's minus 42. Excuse me. So we are done with with the third column. So we need to proceed to the fourth column. Now we are multiplying by the second row of the first matrix. So 3 times negative 1 is negative 3. Then 5 times 5 is plus 25. Then negative 6 times negative 3 is positive 18. So what we need to do is just to add those numbers which are inside the brackets, and we'll get 21. Then when we add this, we'll get 8. When we add that, we get 10, we add this, we get 25. Then similarly, on the second row, negative 18, 2, and 40. Let me confirm. Negative 3 plus 25 plus 18. So it's 40. So you can also go ahead and check. So which means you can multiply matrices of various orders. What you need to do is to check using this concept. Just check if you can multiply. So it means that even here, let's see if we were to reverse it. It's going to be 3 by 4 and a 2 by 3. So it means that we cannot multiply, we cannot get BA. So BA is undefined. So thank you for tuning in. We will end here today. In the next videos, we will look at determinants, inverse matrices, and how to solve linear equations using matrices. Thank you.